Hi everyone, it's a Thursday, we're talking tech, so it must be a Tech Thursday. For those joining us for the first time or from outside Derivco, I'm Lee Naidu, part of the branding and communications team here at Derivco, and I'm also your host. I know we are all in the middle of OKRs and it's a big ask for you guys to be here, but trust me, today's session is a goodie. It's a topic area that most of you have been asking for, and it will be presented by Chris Olivier, Senior Data Technical Lead. Chris has been described to have an unhealthy love for data, which is a bit alarming, but for our purpose for today, I guess this is awesome for us. Before I hand you over to the speakers, let's just have a look at our agenda. First up, to officially open the event, we have Paul Francis, Software Dev Manager. Chris will then deliver his talk titled Modern Data Processing with Azure, which should run for about an hour, followed by a Q&A session. We then head back to Paul to say a few last words, and then it's back to me to wrap things up. Regarding questions, they can't be asked verbally, so type them in the Q&A tab. Also, Derivco is all about transparency, so please no anonymous questions. We also like to know who we're speaking to. I think that's all my house rules done and dusted. We hope you enjoyed today's session. Feel free to comment, share on social using the hashtag Derivco Tech Thursday. We're active on Facebook, Instagram, LinkedIn, and remember to follow us on Stack Overflow. Enough from me. Let's get the ball rolling. I know Paul is ready to get the show on the road. So over to you, Paul.
Thanks, Lee. Hi all. Thank you so much for taking the time and joining us on this webinar. I'm very excited to be here and part of this wonderful community. Tech Thursday is an amazing platform for us to connect whilst most of us are continuing working from home during this pandemic. Tech Thursdays focus on encouraging growth and development of skills, knowledge, and technical abilities that drive continuous improvement, which is at the very heart of Derivco. Before I introduce the star of the hour, I will take a brief moment and steal the center stage to explain who I am and what I do at Derivco. My name is Paul Francis, and I work as a software development manager at Derivco. I've been with the company for the last 2.5 years. My job involves setting the vision and strategy of software development within the data team. Since day one, the data team has been pioneering in cloud technology to solve most of our everyday data problems. Our choice of cloud has been Azure, as it has offered the best capability for us to keep our data moving reliably in a fast and secure manner. For someone who uses Azure daily, I'm still amazed with all the new features and functionality that comes along, which 2 months ago would not have been available. As a data team, we are in the business of moving data from A to B. There is always complexity when it comes to moving data. One such problem we faced was the ability to ensure that the right people would receive the right data, making sure the data in transit and at rest is kept secure. This has and will always be our utmost priority. For us, security has been the biggest selling point using Azure. The reliability offered Microsoft, the multitude of services that come along with geo redundancy and or failover capability, the ability to bring your own key for encryption of data at rest, the possibilities and ease of managing resources with templates, making maintainability very easy. This, of course, is a very small list of what Azure would offer. Even if I'm here talking here about Azure, what it could offer, I would still not do any justice to it. So instead, I'm going to introduce Chris, who is going to give an amazing introduction on how one would process data efficiently with Azure and how it could benefit any organization. Chris joined my team 2 months ago, 2 months after I started in 2019. I thought I was crazy about data, and then I met Chris. I was pleasantly surprised that I was not alone in that journey. Chris's passion goes beyond just data. He is very interested in technologies that support data processing, coming up with solutions and making real-time data processing a reality. Chris has always been the go-to person for me personally, if I need to bounce off ideas or to correct me when I'm talking utter rubbish. Chris and I share the same ideology when it comes to how we work. Do it right the first time, so we wouldn't have to go back and fix it. There has been evenings and nights where we would be on call for hours, working on live share coding, working on the same code on different sections, and we get stuff done. Chris's background skills with BI and traditional databases have played a vital role in becoming the technical lead in the data space. His current focus within the data team combines his past and current experience in providing optimal solutions. I'm really hoping this presentation would spark the interest or would contribute to the already burning passion in someone to take data processing to the next level. Without further ado, Chris, over to you, buddy.
Hello, everyone. Thank you very much for the wonderful introduction, Paul, and for you guys at the Durban side hosting this for us. And yes, for everyone who is taking some time out of their day to attend this, I really do hope that you guys will find it interesting. So I'm basically just going to jump into it. Basically, what we want to do today is we want to talk about some modern data processing techniques. And what I want to do personally is to take you guys on a bit of a journey to explore modern data processing in quite a general fashion, but with a focus on Azure technologies, because that is what we have chosen as our stack tech. So where we will start is by looking at processing from files. So this is direct processing from data files, and even though it may actually seem a bit ancient, it is actually growing in popularity these days, especially with the advancements of cloud technologies like Azure. So what we will do is we will look at why we would want to do this, and also what allows us to do this. So to get started, we will look at how we are trending back to processing data directly from files. And we will start our journey in a little time called 1960. But don't worry, we're not going to go through the entire history of database design and relational model growth and all of that. We will just take a brief look at what we did at this point in time. So back then, there was no such thing as a relational database. And what we would do is we would take files, we would be writing some code, which basically loops through all of those files, produces some form of an output. And this output we will then use for our analysis. So there was a couple of flaws with this process. And there's actually a few more than these four, but we will start with these four in this talk specifically to look at how we can solve these. So some of the flaws that we're talking about here are slow access times, the presence of redundant data, difficulty in recovering corrupt data, and then also the obvious lack of things which we love as SQL developers of asset and relational structure, etc. So two of these flaws are quite easily solved by the natural progression of technology and advancements in hardware. And we will actually look at those first. I was initially planning on asking if someone wants to take a stab at which ones those are, but I think we'll probably not be able to do that. So the two most obvious ones which I actually think about in this case is the slow access times and the difficulty in recovering corrupt data. Now, this is actually quite easily solved just by modern technology in the form of something like blob storage. If you look at even the lowest tiers of blob storage, you get very, very fast access times and write times and things like that, because the backbone of Azure is extremely fast. We also do actually look at the difficulty in recovering corrupt data, and for this, blob storage gives us quite a few tools to work with. We have tools to be able to make sure that everyone has the correct access at the times that they need it. We also have things like soft deletes, and this allows blob storage to give us multiple levels of redundancy. So if we talk about redundancy, etc., we look at two main classifications: availability and redundancy. So even on locally redundant storage, which is the cheapest option, you actually get 11 nines of availability. And we also get 3 copies stored in each region. Okay, this means that even if 2 of the data centers in a region has to go down, you will still be able, there will still be 1 data center which has a copy of your files. If we look at globally redundant storage, we up that to 6 copies and 16 nines. Okay, so that literally means 9.9999999 up until 16% of the time your resources will be available, and that's guaranteed by Microsoft. In the case of globally redundant storage, we have 3 copies which are stored in your primary region, and then another 3 which will be stored in another region, which will be at least 100 miles away. That means even if an entire region has an outage, your files are still available. And that's quite impressive if you think about that. And that basically takes care of 2 of the issues that we used to have with regards to processing directly from files. At this point, I would also like to point you to a talk by a guy called Mark Krasinovich, who is the CTO of Microsoft. And he gave a wonderful speech at one of the Ignite sessions where he where he takes you through the internal workings of a data center and what Microsoft is foreseeing for the future. And I would highly recommend that everyone goes and actually has a look at this. Someone will post this link for you guys in the chat so that you can go and watch that at some point. It's really super interesting. And just an example of how interesting this talk is, Mark's presentation where he was talking about the Mega Godzilla Beast, which is at the moment the biggest server that Microsoft is running. He took the task management CPU analysis and by writing some code, he actually manipulates the picture which you get from looking at the CPU usage to play Tetris on it, right? And then he went and created a breakout game as well, using the 420 odd CPUs that this Mega Beast server actually owns. So that's very interesting. And just to take things to the next level, he then decides to show everyone what real liquid cooling actually looks like, where he literally takes a motherboard and shoves it into a pool of water to keep it cool. So this is definitely worth looking at. And I would encourage you to please go and do so. So this is all great and everything, but just having redundancy and access times doesn't necessarily allow us to achieve the amounts of data processing that we really want. And this is where we borrow from concepts that we learn from parallel processing to analyze data in a non-database world and a non-database engine world, right? So in this world, we distribute our data processing across worker nodes. And these worker nodes will process each their little section of data and return some results to the head node. And the head node will return the results to the user. Okay, so this is one way that we can do parallel processing. And for another way is when you simply process all of the data in parallel. So as streams of data come in, you manage them in parallel, and that output gets handed off to another input, and you can continue working. Okay. But why would we actually want to do this? We already know that databases are optimized to work with data. And the answer from this comes from a big buzzword, which is big data, right? And in big data, if we just look at the 3 most common V's of big data, volume, velocity, and variety, the two of them, volume and velocity, is not necessarily as big an issue unless you have very large amounts of data. And servers can scale vertically to a degree to accommodate quite a bit of volume and velocity. The portion which I'm more interested in is the variety, which becomes a problem at even the smallest of data sets. So if we look at relational databases, they love structure. And with variety of data, the first thing that really goes out the door is structure. And that makes it really difficult, even on the smallest of data sets, to work with data which has varied types of data. And I'm talking about images, videos, IoT device, any such type of things. Okay, so that becomes a problem even at a small scale. Okay, so that's why we want to rather make use of something which isn't as tightly coupled with having structure. So if we look at a traditional world on how we would process data as we get it in, we would start off by using integration services, right, to move some of the data into a database. And from the database, we would build some cubes in analysis services. And from there on, we would end up presenting that data either from the database or from analysis services into reporting services or Power BI. Okay, this does mean that we would generally massage or force our solution to fit in with these technologies and this technology stack. And that becomes a bit of a problem for us later on. So what we want to do is we actually want to look at how can we get around that and do things in a bit of a different way, which gives us a bit more flexibility. So what we'll look at for our first demo is how we can process data in Azure by tying some resources together and processing the data not using a database engine. Okay, so you will realize that I am completely blowing the solution out of the water, and I'm basically using a sledgehammer to drive in a nail. But what I wanted to get across is how many different resources we can chain up to do an exercise which will be very easy, but you will see where the flexibility in everything then lies by tying modular technologies together. Okay, I'm going to quickly go through what we will do in the demo just so that it makes a bit more sense, because as everyone knows, data processing isn't the most visually appealing thing. So it will be difficult to follow along unless you know exactly what we're going to do. So we have some files. We have 10 files which sits on a blob storage. And this is with regards to sightings of animals within South Africa by province. And what we want to do is we want to process these and aggregate them together. So we'll start off by using data lake analytics, which is a technology that uses a language called USQL. And USQL is C# and SQL mashed together. And what this allows you to do is to process files directly from blob storage or something similar, and eventually break it up into a data set, and then you can query it using normal SQL language. So we'll first grab those 10 files and do some pre-aggregation on that to make life a little bit easier. Then we will place these the end result of this on a data lake again. And then I would like to show what Data Factory looks like. So Data Factory is similar to SSIS, but this runs in the cloud. And its main purpose is moving data around And recently, they also added in data flows in Data Factory, which people who are familiar with SSIS will actually appreciate a lot, because it's quite similar to what SSIS looks like, but you can actually run this in the cloud. Okay, so we will, in our case, all we will do is we will take that data from our initial data lake and we will move it to a separate data lake, just because we can. And you will notice that these things will happen automatically because they all run on triggers. So we don't want to do manual things in the meantime. We literally just want Azure to handle all of that automatically for us. Then we want to make use of a function to take that data and do some additional processing with it. Okay? Because what we realized at that point was that people were classifying some animals as a rhinoceros. But after some more investigation, we realized that actually they were slightly overweight unicorns. And the data is incorrectly captured as rhino. So we want to fix that, and we want to fix it as these files are being processed. After that, we're going to place that new file on another blob storage account. And then we want to make use of a technology called my headphones audio cuts out every hour for some reason. But I believe I am back. Anyone can give me an indication if it's working again?
Yeah, it's all.
Okay, thank you. Sorry, I can't do anything about that. It's just how it is. So we will be making use of Databricks, which is actually a technology that is more centered towards data science. But what it does is it makes Spark cluster management really easy. And I will show you some of the cool things about Databricks during the demonstration as well. So we can actually get started with that. I'm going to drag some stuff over here, and then we can have a look at that. So where we are starting off with is our 10 files, as I mentioned. And these 10 files look similar to this. So we have city, province, date, and the animal which was seen. And all of these, all 10 files have some random values of this. And you will notice that in here somewhere where, yes, surely enough, someone has gone and made that mistake and believed that they saw a rhino. So what we'll end up doing with it is something similar to this, which you can do in the pivot table, not like that. But we want to do it for all 10 files. Okay, so what we will first do is to use Data Lake Analytics. And like I mentioned before, in Data Lake Analytics, what you can see here is, if we just do that, is that we will take the files from our container, which is this animals container, and all of the files which has this prefix. We will first collect all of the data in a little data set, and then we can make use of the SQL part of USQL to just run a query across that data. What's wonderful about Data Lake Analytics is that it handles all of the data movement and everything for us. We can also quite easily scale this and say that we want to actually run this on 32 analytical units. And if we want even more, in the hundreds or even thousands of these analytical units to do something really quickly, we can actually ask Microsoft to do that. For now, just to keep it interesting, we'll keep it on 5, which is completely unnecessary, but why not? So how do I get out of this? There we go. So what we will do is we will submit this job, and then I'm going to switch over to our Data Lake Analytics job monitor. And what we want to see there is that the job will get triggered, and we want to look at our data factory to see the job getting placed on there. And I want to pull across my function. And I'm going to start my functions along. And this process will all be completely automated. Everything will trigger as it goes along. And this trigger is the one which actually has the most interesting information. So the trigger function will run. That's just because it's still starting up. And we want to see the outputs at this point. The other output that we will see is on each of these storage accounts. We will see our data get populated, and eventually we will we will run our stuff in Databricks to see some results. Right, so to just give you an idea of what each of the components will do, we have our Data Lake Analytics job sitting here. The data factory will get triggered. So we've got a trigger which monitors the data lake. And when a new blob arrives, which carries this signature, it will pick it up and it will perform whichever action we have defined in our pipeline. So take into account that this pipeline can be anything from moving data, from running stored procedures, doing data flows, anything like that. And it will be optimized for running certain processes. We will then pick up the file with our function. And what's nice about our function is that there it's very general programming. You can use C#, Java, JavaScript, and basically program anything that you can think of, and that will be performed on your data. And then we will end up in Databricks. So I'm going to kick off this guy and then move on to our monitoring screens to see how this process is going to run. Maybe. Okay, so our Data Lake Analytics job is busy running. It will take a couple of seconds to show some results. In the meantime, you will see that the function gives a bit of information to say that I'm still busy running. And the Data Lake Analytics job is the one which we are most concerned about now. It will run a couple of seconds because in this case, what it's doing is it's dividing up the job across the analytical units. And this is something that you have to take into account with processes like these. So Data Lake Analytics is not really created to do on-the-fly real-time analytics. It's made for doing bulk processing. So the initial, you do pay an initial overhead to get the process running as the job is being distributed across to our nodes. But then from there on, you get the wonderfulness of parallel processing, and the results of that will be very quick. So you'll notice that our function has now actually picked up that we have our data, and it's gone and done some stuff. If we have a quick look at, mostly I'm just printing out all of the data. But you will, somewhere in between here, we will see that we have gone and made some changes to fix the Rhino issue. So that is, if we look at our data lake, we will end up with our end result, which is that count that we want per province and per city. Okay. And the next portion is the more visual section. So here we're going to be looking at Databricks. So what Databricks is going to do for us is We have a Spark cluster, which we just need to start up. And this Spark cluster gets provisioned very easily, and it's managed by Databricks, okay? Which means that we can quite easily spin up and manage one of these clusters, and we can perform queries on them. If you've worked with Python, then this notebook section will look quite familiar, because Databricks has borrowed from Python on this whole cell structure of notebooks, okay? What makes it a little bit different is that you will notice that I've got these little kind of tags in these cells. And what this allows us to do is to say, this cell, I want to make use of Python. So I want to run some Python code here to initially import my data. Then or to make the connection. Sorry, I'm making the connection here through using Python. Then I want to make use of Scala to actually import those that file. And I want to put that data into a data frame. From there, I want to put that data frame into a view, because a view can be understood by SQL. From there, I want to run SQL. And what I want to do with it is to do some aggregation on it. So this is very interesting to me, at least, is that you have this flexibility around choosing whichever language you want to do something in. It obviously doesn't support all languages, but all of the common ones. It also supports R, etc. And you can literally, between these cells, switch between that, and you can run your queries as you want, or your code. So something that you guys will also notice about this whole process is that there's a lot of flexibility around what you want to do. And that's the biggest selling point for me, is that you have all of this flexibility which you didn't have before. We can choose to do some of the processing using data lake analytics. We can then choose to do some of the processing in Data Factory if it's something that Data Factory handles a lot better. We can then choose to do very general programming by making use of functions. And we can use something like Databricks, which is geared towards data science and machine learning, etc., to process this. So if we run these guys, we can actually just go ahead and run all of them. So each of these cells will go and do its little part and hand over the processing to the next cell. And remember that this is being done on a Spark cluster, which is also making use of parallel processing. And what we end up with is something that looks like this, where we actually have our little graph of our data, where we can say by animal and by province the number of sightings that we actually saw. And there is, surely enough, our slightly overweight unicorns has actually made it in there. All right, let me quickly see. Why does this not return any results? Why did I decide to write this at the wrong time? On the cell. Okay. So some nuances that you will notice about this is like the SQL is slightly different than you would see in a normal database. So obviously this is actually case sensitive. So you can't just go and write this as with a small letter, because it will just say that it's unhappy. And that is mostly what I wanted to show with this demonstration. So I shall get back into the rest.
Very quickly, Chris, there is a very good question that has just popped in, which is, could we do all of the processing with logic apps and use Databricks as a job?
Do all of the processing in logic apps and then use Databricks
as
a job. As a job in which sense, though?
As a job to actually do the classification. Processing of the file to be done on logic apps and then get the output and put it into Databricks to do the classification for us.
You probably could. I don't know if I would really use logic apps for that though, because I'm kind of worried about the scaling of how well that will scale. I'm guessing you can, and that's the wonderful thing about Azure, right?
Yes.
Is you can actually go and hook these services up as you kind of want to. I don't know if I would personally choose logic apps to do massive amounts of data processing like that, because they are better ways or more performance ways. I don't know if logic apps has a lot of different connectors, and it's got a lot of flexibility. But as far as the amount of data that it can handle, I would, and how you're going to manage the scaling, etc., I would probably rather make use of serverless functions. So like these functions that we looked at here, because in that case, you can attach this function to a service app, which you attach to a service app plan. And that plan, you can manage exactly what type of server you want to run it on and how many instances you want of that. And you can have rich monitoring around seeing how it's performing and when it dies, what has actually gone wrong in your code.
Absolutely. I mean, there is always the flexibility that there is a solution for everything, I would suppose. And which one do you want to use is the bigger question.
Yes, it'll depend on your amount of data and the amount of code that you actually want to write. So if you're not looking at a lot of data and you are someone who doesn't necessarily want to spend a lot of time on writing code, then yes, you can actually do that and hand over the files to Databricks and live your life happily.
Thank you very much.
Cool, thank you for the question. All right, so there are a couple of things that I wanted to remark or to show in this demonstration. And the one thing which I hope is very prevalent is that you can take these little, not necessarily little services, but you can take all of these services and you can build them together almost like Lego. And all of these services interact with each other, and each of them can actually automatically trigger another one. And in that way, you can chain these things together and make sure that the type of processing that you want to do, you do with the correct technology. And and that you'll see is quite a bit different from our traditional look, where you were trying to get your solution to fit within the constraints of the technology. Now you basically say, what is the solution that I want to do, and which technology can I use to achieve what I want to achieve? Okay, so just for some closing notes on the processing that we just did, like I mentioned, we have USQL, which combines SQL and C#, and it gives quite a bit of familiarity for SQL developers, and you can run queries over a data lake, right? The data lake is a very general storage technology that we made use of. Data Factory has a specialization in data movement, and it's also included data flows recently, where that has been in preview for quite some time, which is really nice if you come from an SSIS world, because then the transition over to using Data Factory is quite easy, and you can always later on go and pull other sections out of that. Once you've migrated everything directly onto Data Factory, you can go and then see, does it make sense to have a certain component within that, or will it make sense to rather pull that out and do it in a function or something like that? Which then brings us obviously to the functions. And the wonderful things about functions is that's super flexible. So your only restraint there, or constraint, is how much your knowledge around C# or Java or JavaScript or something like that is. But there you can basically do anything that you can think of with your data. This is also super fast because it's serverless functions, and you're literally talking about millisecond processing time for whatever you want. So you can always scale this up and scale this out, and it's very, very flexible. Okay. Then we looked at Databricks, which for fully creating a graph is really, really unnecessary. But I think it kind of brings across the point that you can then use Databricks for some of your processing and for your presentation layer, because there's a lot that goes on with Databricks except for what we showed here. But obviously, due to some time constraints, we can't really go into too much detail on that. And the thing that I think is quite obvious here is you do get rid of the automated optimization which a database engine gives you. Okay, you don't really have that luxury here. But what you do get is an exponential growth in flexibility, because you are no longer tied to whatever the database engine supports. You can decide on what you want to do with that, and that can be quite daunting in the beginning, because you will notice that we're working with USQL, which is a different language. We are working with Data Factory, which has its own nuances. We're working with C# or Java. In Databricks, we're looking at Python and Scala. And all of these new languages can be very intimidating in the beginning, but upskilling on those is not really that difficult, and it's a super rewarding process to know that you understand how data is manipulated and how data works, etc., at a very much lower level than just writing a query and hoping for the best that the database engine will know what it needs to do. Cool. So for the next section, we will actually be looking at something a bit more familiar, which is in the sense of Azure dedicated SQL pools, which is the data warehouse platform in Azure. Previously, Azure dedicated SQL pools was known as Synapse, and before that, it was just simply known as Azure Data Warehouse. But it's gone through some changes, which meant that they just naturally progressed the name a bit. So in this step, I would like to show you guys a little bit of this. So I think anyone who's worked with analytics will tell you that at some point you will need to have your data in some form of a structure to be able to present you with something like a graph. Okay, and that's in that sense you will at some point revert back to making use of some structured layer at some point. And dedicated SQL pools actually works quite well with this if you have large amounts of data. So dedicated pools, which for all intents and purposes, I'm just going to call data warehouse from now on, because dedicated pools is a long word. So what makes this quite cool is that it's not really a traditional SQL database. It's also a distributed, parallel distributed database. So like with the same technologies that we've mentioned before, you actually have a whole bunch of worker nodes and a head node, and this will look quite familiar because we had the parallel processing picture before. And our worker nodes or our head node will pass jobs along to the worker nodes, and our worker nodes will return the results to their head node after they've done some aggregation. So what's nice about SQL Data Warehouse is that it is basically just SQL. So it's very familiar and it works really well. There are a couple of nuances though, or differences with regards to Data Warehouse from traditional SQL. And one of the most notable things is that the compute is separated from the storage. Okay, this allows us quite a bit of flexibility because now you're not really as much worried about all of it just being one massive thing, because your compute sits completely separate from your storage, and that allows us quite a couple of things which we will actually be looking at soon. One of the other cool things about it is that the scaling works quite well. So you can scale from 100 data warehouse units up to 30,000 data warehouse units in Portal, and you can go almost as much as you want by simply contacting Microsoft and saying, I want to pay you a lot of money to have unlimited processing power. With the compute being separated from the storage, that also does mean that we can actually pause the compute, which is a very cool feature in my mind, because that means that if you need to run some form of compute, which takes a lot of power, you can go and scale this compute up. You can start the compute, you can do your analytics, you can get your results, and you simply pause the compute. You don't lose any of your data, and you don't pay for the compute. Obviously, you still pay for the storage, but in this case, the storage is not nearly as much cost as the compute. So this literally means that you can, if you had a report which used to take 4 hours to generate, you can tell someone, well, if you are willing to pay, let's say, £200 for 20 minutes, so we can run this, you can actually have that same report within 20 minutes. You start it up, you run your query, you pause it, and life goes on. The downsides to data warehouse, though, it's not completely without its downsides. So some of the downsides, which I find slightly annoying, is that it doesn't support all of the formats that SQL supports. Probably the most notable one is that you can only go for strings up to n-varchar 4000, which is quite limiting. It's also got a very strict format definition. So we will see when we get to the demo on Polybase that you have to be very strict with how you define your data types. And also you have to look at your distribution strategy. Remember that your data and your processing is going to happen across multiple nodes. This actually goes, for some reason, they decided to do exactly 60 nodes for each data warehouse. So you will have 60 nodes, and your data needs to be distributed across these nodes. And if you don't do your distribution properly, you will have a lot of data movement between the worker nodes, which means that you will have quite a bit of overhead that you need to pay for there. So there's a couple of things that you have to keep in mind, but if you have it up and running, you can actually get very good results. And one of the things that I can kind of mention is a while back we were doing an exercise for someone, and a normal on-prem SQL data warehouse, they were trying to run a query which took about half an hour, and then it didn't return any results. After moving everything onto a data warehouse, within a couple of seconds, that same query finished. And that was only at 1,000 DW units, data warehouse units. So it's really super powerful. All right, and something that will take us to the next demonstration is how we actually get data into this data warehouse. Normally, you will have some request which pushes the data through to the head node, and the head node will distribute the data. But if we want to optimize this, we can actually make use of something called Polybase. Okay, so Polybase, what makes Polybase really cool is that Polybase skips the head node and it interacts directly with the worker nodes to load the data in there. And that means that your bottleneck, which is your head node, goes away. And as an example, not too long ago, without doing any optimization really, we loaded about 500 million records into the data warehouse within about 9 minutes, which is quite astonishing. Cool. So we will be doing a quick demo on that, just to show a little bit about what Polybase actually is. And what I have here is my data warehouse. Stop that guy. If I can find it. Okay, I've got my Synapse data warehouse here. And this is only running on 100 data warehouse units. Oh, I need to actually start this up. So you'll notice that what I did here was to save some costs on my poor MSDN free credits. I did pause this for the demo, and it's actually quite quick to just get it up and running again. Let's see. Come on, guy. Did it start up? Am I going crazy? Oh, okay, well, it has received it, so it should be up and running soon. And I didn't really want to leave it running because it will take my credits within a couple of hours. In hindsight, I should have probably kept it running. We do have a backup in case this doesn't come up in the next couple of seconds. Hopefully it will. Let's see if it's running. Okay, I am. There we go. It is starting to get up, and it's immediately being bombarded with some queries, so it's going to be slightly unhappy. All right, so in this case, what I have here is just some cleanup of some resources, which I will just first run, and then where we will start with this is that to interact with the blob storage. I think I can do that. Yes. To interact with the blob storage, we need to create some credentials. So we create a master key, a master encryption key on the database, so that we can encrypt all of the communication. Then we tell it that we will be making use of an external data source. And this is now where it becomes interesting. So Polybase needs us to define a format for the file, because obviously it needs to know what it actually needs to run, right? So we create a file format for it. We tell it that it's going to be delimited text. It's comma delimited. It will need to start at row 2, and it's got some string delimiters as well. And this is the section which I spoke about earlier. So we need to be very specific in defining the data types. For comma delimited files, it's not as prevalent, but if we look at data formats such as Parquet, where the metadata is saved within the file, we do need to be very specific about what data types we are looking at. And now you'll see something very interesting. This data is not loaded into the data warehouse at all, okay? It's just a delimited file. However, we can actually query that file from SQL Server as if it is a table in a database, okay? So what we want to do now, though, is we want to persist that data in the data warehouse. So I'm literally just going to create a new table from that external table. So I'm creating my table, and here you'll kind of see that things should go relatively fast, and where it will go even faster is if you are working more in bulk. It will be able to distribute that data, and it will work a lot more efficiently. And then our data actually is just in our data warehouse. And we'll see kind of similar figures than what we saw in the other demo. So that is kind of it for this demo. Unfortunately, because of things like the amount of credits that we can actually spend, I can't really show you a demo where we load millions of records, etc. But at least I hope that gives everyone an idea of how you can use Polybase to either query data into a data warehouse or directly from a file. And we will get into a little bit more detail around why we want to do that soon. Oh dear, are we slightly late? Okay. It will not be that much longer. So the other file processing issues which we mentioned earlier, which is data redundancy and the lack of atomicity or relational design, right? We haven't really forgotten about that, and we will cover them quickly. So data redundancy is something which databases normally handle because of things like foreign key constraints, primary key constraints, and things like that. So that is normally a bit of a worry with regards to non-relational data or things like file processing, etc. And how we handle that is we don't actually mess with the source data. We leave our source data as it is, but we make use of derived data sets to then filter down that data set or process it into something that we actually want. So we can have a process which will take that original data and then do deduplication on it and create a new derived set. From there, we can create another derived set to do aggregation. And this is quite a common practice. And the reason why we can do that is because storage has become a lot cheaper. So this does basically take care of the data redundancy, and that's how we generally handle data redundancy. Also, this does allow you a couple of places where you can go and change your processes. If you've loaded data into a data warehouse and you've done it wrong, you are generally in a bad place. But in following this method, you still always have your original data, which is your source of truth. And then you just filter that down into what you actually want to be able to draw reports from it, okay? The other issue is with regards to something like ACID. And there we actually need to ask the question of, do we actually need ACID and relational design, etc., in a data warehouse or for analytics? And this is the place where lots of people will get slightly angry with me. But if you really think about it, generally what we do is we actually end up fitting data warehouse and analytical solutions into an ACID and relational world because it's there. You have a relational database and you need to fit your data in there. Okay. All right. The next step, we will quickly have a look at non-relational data and why that is not really an issue with regards to analytics. Okay. So initially, you will catch a bit of a fright with regards to non-relational databases. But like I mentioned, it's not necessarily an issue for analytics. And if we look at some modular ETL design, we have actually in the past already found ways around this. And this is even on a database. So how this would normally work is if you want to load data into a fact table, but you don't want it to be dependent on your dimension tables, you would load your data in your dimension table. And when you load your fact table, and maybe you have a new product which wasn't there in your original products table, you would create a dummy record in your products table, which is just a placeholder. And you will make use of surrogate keys to actually link it back to the original fact table. Okay, so this is basically making use of something which has been there for other purposes. So surrogate keys were originally designed for something completely different, but we found ways of using it to create modular ETL in a traditional database world, just to get around the fact that you need to have relationships between tables, etc. Right? So in this case, what will happen then later on in a modular data warehouse ETL is when the late arriving dimension then comes, that will simply update your dimension table, and all the relationships are still in working order and everything works as it should. But in this case, you don't have to worry about your sales load being dependent on your product load. So this is something that we've already actually solved in a relational world. And that's why I don't really think that it's really a problem within analytics for a non-relational world. This also does allow us to do analytics directly from files. Okay, so this is something I mentioned earlier as well with regards to Polybase, where we can create an external table on a file. And what you will notice that people will do with this is to almost skip out on loading data into a data warehouse completely. And what does this actually mean? That means that we have come up with file structures, things like Parquet, which is actually a column store file. And it even saves metadata, which means that you can actually do analytics directly from a file by simply loading those files into blob storage, using Polybase to create an external structure on that file, aggregating it and placing it in a database, in a separate file within a storage account, and then you can directly serve Power BI with that, without even loading any of your data into a database. So you will notice that there's a lot more flexibility around all of these things about how you actually want to solve a problem. Okay, the last step, what I would like to pull everything together with, and I think that's something that everyone would have noticed that I've been trying to get across here, is to use the correct tool for the job. Okay, we've been conditioned into trying to solve or mold solutions around the technology that we have. But if you look at the myriad of tools that you now have within technologies like Azure, you can have the flexibility of using the correct technologies at the correct times to make your process very efficient. Okay, and personally, I find this to be a very exciting time where we're not really restricted by trying to solve a problem with a specific technology, but we can rather say what technology we want to use to solve the problem. And even if this looks daunting initially with all of these little services which are tied into each other, you quickly pick up on that. And I find it super exciting to go and find how can I create a solution, because officially what Azure and cloud technologies and these things have done for us is to not limit a cat to being skinned in 1,000 ways, but now you can actually skin a cat in like 1,000,000 ways, right? And what it also has introduced is modularization in data processing, where modularization was normally reserved only for things like programming, etc. But now you can actually start modularizing data processing, which is very exciting. So if there is only one takeaway which you get from this presentation, I hope that it will be that there isn't just one silver bullet to solving data processing problems. You can actually find the correct tool to solve a problem and not use the incorrect tool to do it, and make it fun and easy. Thank you for your time. That's it. Over to, I think, Lee.
Thanks, Chris. We'll just start the questions now, and I'll hand over to Paul, who will be posing them to you.
Cool.
Paul, I think you're on mute.
Oh, sorry. There we go.
And you're frozen.
And I'm frozen. There we go. Is that better?
Yes.
Yep. Cool. So I think we already answered one of the questions, which is using the data logic apps to whether we could use logic app. I think that sort of summarized at the end of your presentation is using the right tool for the right job. I think we could, but is it the right tool for this particular data processing? Maybe a question mark. I think that is a good answer. We don't really have many questions unless there are still coming in. I'll just wait for a few more minutes for people to type in their questions.
All right. I like Rory's comment. Yes, generally, well, when I started to need to do more stuff on C#, I was not always impressed because I enjoy SQL, but after a while you get to love C# as well. Does Databricks support machine learning packages? Yes. So Databricks supports basically anything, any of those libraries. It'll probably have quite a lot more because you can make use of Python, R, Scala, and all of those libraries are also supported. So you can have it import those specific packages which are not included just by default, but a lot of the packages you will notice it just has already built in from the start. So when it spins up the Spark clusters, it already installs a lot of those. So yes, it does.
Cool. I'm not sure if any more questions are coming through. Just a lot of thanks and celebrations of the presentation. I think we'll call it for now. I'll hand over back to Chris just to say a few last words.
Yeah. Thank you very much. Thank you for everyone joining and for everyone who stuck around. I really appreciate it. I hope that it was not as much of a sales pitch as some webinars may sometimes be, and that it's more of an informative thing, and that it's kind of encouraged everyone to want to explore all of these different tools and seeing how you can actually fit everything together. So yes, thank you so much for your time. Really appreciate it, and I hope that everyone enjoys it. Oh, more questions.
Yeah, there are a few questions coming in now. So there's one question from David who says, what about using Cosmos DB for non-structured data? Is it suitable?
Yes.
I believe the issue could be because of the variety of what the data looks like, because blob storage, as you mentioned earlier, Chris, is the fact that you can store variety of data and you can process variety of information, whereas a non-structured DB would, like a Cosmos DB, would be more around the semi-structured data that will need to be in there.
Yeah, so Cosmos DB is not for unstructured data, it's for semi-structured data. So your JSON documents and things like that. So for non-structured data, you would look at something like Databricks or something along that line, or maybe something which is a bit more general like C#, etc., where you can actually process images, etc., with libraries.
His headphones gone. Sorry.
So it's
Yeah,
every.
he's
All
back.
right.
Oh, because I think he's lying to us.
Yes.
Yeah, you're back now, Chris.
Yeah, thank you very much to my headphones for their awesome dropping out capabilities. So yes, Cosmos DB is more for semi-structured, but for non-structured, I would definitely say you want to use something like functions or something. And if you and if you're looking at large files that you don't necessarily you can't do, because functions are designed with time limits. They're supposed to be fast running. They're not long running things. But if you have more long-running things, then you would look at something like Databricks, or even just native Spark clusters. If you want to go through the trouble of actually creating your own Spark cluster, then you would use something like that. Or also as is included in Azure, but Databricks is a little bit expensive because you get what you pay for, but it makes life so much easier. Because anyone who's actually ever had to spin up a Spark cluster will know that it's not the easiest thing to do. People who I know are like super good at doing the lowest level things on Unix and Linux, and so even they will tell you that yes, creating Spark clusters and managing them is not the easiest thing. So Databricks will probably be a good way to deal with unstructured, like fully unstructured data.
Cool.
Advice.
Cool. There is a question from Alistair who wants to know if there is any advice with regards to ensuring data quality in data factory pipelines. Are there any checks you can perform on the data, and can you send out alerts or emails when you pick up errors?
Yes. So Data Factory does support all of that. Basically similar to what SSIS used to be. So you can at each step have a failure path, which if any of the steps fails, it will trigger something, and that trigger something can be email, it can be webhooks, it can be basically anything that you can really think of. So you can even have custom C# scripts in there, etc. So yes, you can quite easily do that. You can also include other checks within it to kind of like check itself to say, I expect that this should be this many records, and if it isn't, please follow a different path. So obviously the example that I used there just had a copy data thing, but you chain those together, all of those different resources or the different tools you chain together, and at each of those levels you can include failure paths, you can do certain checks on certain things, etc. And if you go into a little bit of a lower level into the data flows, then you have even more control over that. But yes, you can definitely do that. Data Factory basically takes over from SSIS, and it actually supports a lot more than SI used to. You will notice that Microsoft has kind of stopped really releasing new features on SSIS, but you will get all of that goodness in Data Factory going forward. I hope that answers the question.
I hope so too.
Anything else? We been ready. Okay, so I've said my goodbyes. Thank you very much, everyone. Thanks for your time again, and please go and try stuff and do awesome things.
Thank you, Chris, and thank you, Paul, for today. Then thank you guys for tuning in. I personally like that it wasn't a sales pitch. We've been duped previously to into one of those sales pitchy webinars, and we said never again. So thanks for not doing that. But I'd just like to thank everybody for tuning in today. If you'd like to join us for future events, keep an eye on your email and on our socials for invites. Also look out for a short questionnaire that will be popping in the Q&A tab just about now. We want you to share what you liked, what you didn't, and even suggestions on how we can improve these sessions as well as speakers and topics. One last thing, if you would like to rewatch the session, we'll be uploading it to our YouTube page tomorrow, and just look out for the link on our socials. I'll leave it there. Take care, and I'll see you at the next one. Cheers.
Thank you.